so Trent, what did the email you got? It just said you were in close contact of someone that tested positive. Said what? You have to test? Did you test this morning? Oh, well. All right, go ahead and do number one, that first part there. Again, make sure you're telling the calculator there's information in two lists. So this is there twice to remind you that mean and expected value are the same. Or maybe teach you that
Well, no, Sam said it's like, isn't it the same? Like, I don't know, why would they put it twice if it's the same thing?
I'm trying to reinforce, but it might just be confusing. This is, so there's two parts of this unit. There's discrete and there's continuous. This is the discrete part of last year's test. How do you know that? Oh yeah, look how fancy that is. Is that first one okay? I was looking at Ethan doing it last year. So I just remembered. Okay, so if I look at the true false, let's have you try. Try the true false, and then we'll go through them. There might be a couple you don't know. Like you haven't really talked about this yet. Think through it and guess, and if you get it wrong, get it wrong. I'll teach you in a second. these true false are all about combining distributions. So even if there's two distributions, three distributions, four distributions, whatever, the rules stay the same. The Pythagorean theorem just adds like sides to it, even though it's a triangle. You'll see what I mean in a second. But if you are combining distributions, you add or subtract the means, but you cannot add or subtract the standard deviations. You have to square them, add those up, and then square root. So you can think of this as 4 or 2, whatever, but if I'm adding distributions together, do I add their standard deviations? I do not. That is false. I can't add standard deviations. I have to square them. To get to the variance level, you're allowed to add the variances, and then you square root. Some people like this little, so let's say the standard deviation was like 3, and then 4, and then I'm going to combine them. Square it, that gets you to the variance level. Square it, that gets you to the variance level. You add up those, and then you square root it. Then you get back to 5. So you have to like jump up to variance level, combine them, and then come back down. So you can't just add straight across. I don't know if that helps or not. Some people like a little different visual. If I add two distributions together, I can add their means. That is true. If I subtract two distributions, I subtract their variances. The variance is the standard deviation squared. And is there any case in the Pythagorean theorem where we would subtract? So remember, no matter whether you're adding or subtracting distributions, you do the Pythagorean theorem situation, which is adding the two variances together. You would not subtract them. If I subtract two distributions, I subtract their means. Tell me. That was true. Is it variance squared equals standard deviation, or is it standard deviation squared equals variance? It's the second one, right? So this is false. And then if I add three distributions together, I square root the sum of their variances to get the standard deviation. So this is kind of new, but it's actually true. Let's say I had like three distributions. The standard deviation was 3, 4, and 5, and I want to know. I'm going to combine all those. This is new. This is like a little mini lesson right here. I'm going to combine all those distributions. These are the standard deviations. The way you do that, instead of Pythagorean theorem with like two sides of a triangle, you just pretend there's like another side of the triangle. And you go 3 squared plus 4 squared plus 5 squared. And then you square root those. So when I get 3 squared, what is that? Not 9. What, like, 3 is the standard deviation. What does 3 squared represent? The variance. 4 is standard deviation. 4 squared is the variance. 5 is the standard deviation. 5 squared is the variance. So aren't I taking the sum of the variances and then square rooting them? So that's what that's saying. So that is true. But that's not like we haven't learned that before, so we got that wrong. And we'll practice that a couple more times on the sheet here. The bottom part here, did you guys look at this yet or no? So discrete or continuous. Remember discrete, like there's only certain possibilities allowed. Continuous means you can get like any number as possible. So how long does it take you to run a mile? It could be 6 minutes and 2.1 seconds. It could be 6 minutes and 2.15362 seconds. Like that can go on forever and ever. That's continuous. I ask you to run a mile and ask what place you finished in. First, second, third, or fourth. That's it. That's discrete. You score on the SAT. You can't get like a 985.7. There's only like 900, 910, 920. You know, there's so that's discrete. And then your class rank is discrete also. What about GPA? GPA is continuous because, like, if you guys ever look at, I don't know if you see that part of the transcript, but your GPAs are like 3.666587. You know, like, yeah. That might be
I was at a 4.5 until my English grade went down.
So it might be kind of.
It's just a practice just killed it. It slapped it down.
It could be continuous within a window, but there might be like there's no way. Right, but it can still be continuous. It can be continuous between like 0 and 5. It's continuous. Yeah. Okay. So we got some fruit here in a basket. I want the standard deviation of 3 apples, 2 pears, 1 basket. So this is the Pythagorean theorem thing I was saying, but there's like 6 extra sides. It's just a really weird giant shaped triangle. But like if I just said, fine, I'm going to combine these 2. What's the new standard deviation? You would go 0.2 squared plus 0.18 squared and square root, right? No, Logan? Okay. Are you good? Okay. So all I do is just keep doing that with all of the things. So 3 apples, so I go 0.2 squared plus 0.2 squared plus 0.2 squared. 2 pears, 0.18 squared plus 0.18 squared. 1 basket, 1.88 squared. I add up all of those, and then I square root it. So I'm saying Pythagorean theorem, but it's obviously not a triangle anymore. Octagon or something, but do you get what I mean by that? Like you just keep adding, you square it, add, square it, add, square it, add, square it, add, and then you square root at the end. So I got 3.72. So variance might be helpful to just like make another column over here. So how do I go from standard deviation to variance? Are you guys still typing? I think I'm going too fast. How do I go from standard deviation to variance? Square it. So that's on the board. Forget it. Variance equals standard deviation squared. So this is 0.04. 0.0324 and 3.5. Throw this up here in the notes too. So you can add variances. Because the variances are the squared versions. Then you can add those up. So for the variance of 1 apple, 1 pear, 1 basket, you could say, okay, I'm going to go Pythagorean theorem style. 0.2 squared plus 0.18 squared plus 1.88 squared. And then square root it. Let's say you did this and then you square root it. What would you do to find the variance then? You'd square it. So is there any point in square rooting it and then squaring it? No. So you can just kind of like forget that stuff and just add up the variances. So I'm just going to add up these 2 numbers, or these 3 numbers. Yeah. Oh, really? Did I not square root it? Oh, my bad. Thank you. I saw some confused looks. Is that what that was about? Okay, my bad. Thank you. Are we okay in this variance one? 3.6? And then the mean, you just do like whatever you do to the mean, so the data you do to the mean. So this is just like 10 times 4.72 plus 5 times 5.41 this is like a seventh grade question, but it's like way more confusing because you're in the middle of all this other AP stats confusing stuff. But it's just like you got 10 apples, they're 4.72 each, so add them up. You got 5 berries, they're 5.41 each, so add them up. Then you got one basket. Like an 87.5. Question on that? I don't feel that you feel super comfortable with this. Do you agree with me? Okay. So we're not gonna, I was planning on going further, but we're not. Let's go to the back, and I'm just gonna make up another one of those. Alright, we got the golf club, golf ball, and the golf bag. We're looking at the weights of them. Mean, standard deviation. So let's say a golf club weighs 3 pounds, a golf ball weighs 0.4 pounds, and a golf bag weighs 40 pounds. Standard deviation for club, let's say it's 0.5, for ball 0.05, and for bag is 10. What? Let's do this chart again. So mean, standard deviation, and variance. Let's say you got a club, ball, and a bag. Let's say you got 2 clubs, 3 balls, 1 bag. Or let's say we got 10 clubs. Try that one. Similar to the last one. So if you didn't feel super comfortable, this might be hard as well. But then hopefully after I go through this, it'll help. And then we'll definitely practice more tomorrow as well. I think it's super helpful if you go up here and put variance. I didn't give it to you, but like find the variance for each one. And then I think it kind of helps you work through the next chart a little bit easier. club, ball, and bag, if I want the variance of those three things, I can literally just add up those three variances. 2 clubs, 3 balls, 1 bag, so I'd go variance, variance, plus, variance, 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 plus, variance, variance, there. And add them up. So you can add the variances and then work your way back to the square root to get the standard deviation. That's how I did the first one. For the mean, I'm just adding up club, ball, and bag. Add up those three variances, and then square root it to get back to here. Same thing here. So 2 clubs, I'm going to add up the variance for clubs twice. So 2 of those. 3 balls, I'm going to add 3 of these. 1 bag, so I'm going to add 1 of those. Add all that up and gets me my variances. I'm allowed to add variances. And then I square root it to get to the standard deviation level. And the clubs would be 400. Variance will be 100 times 10, so 1,000. And then the square of 1,000. 31.62. Questions on that chart? Did that go better? That was helpful? Okay. Questions on that? Okay. So that was worth doing for sure. So we'll pick up tomorrow. Oh, I did 10 bags. So 30, 2.5, 1.58. Yeah. Okay, but that was better.